Today we welcome to today's edition of our data analysis series lecture. We're picking up important aspects that we consider is important for you to know, and we continue to educate, to inspire you in this new field that has gotten a global attention. So today we want to take you on what data analysis levels of measurement are and why you should understand them as a statistician. If you don't have an understanding of this, the truth is that you have challenges. You have challenges managing your data. And so we want to help you to understand how this data analysis training of levels of measurement can basically help you to analyze data, because this is important for you to know how data is analyzed. It's important for you to understand how data is analyzed. And so we talk of levels of measurement in some textbooks. You hear they talk about scales of measurement, and some call it data types. And so whatever the name is, there are certain things that it's important for you to understand. That a level of measurement tells you how precisely a variable has been recorded. And in data analysis is very, very important, right? Yes. But what is actually a variable for us to see is that a variable is anything in a study that has the potential to vary, has the potential to take on at least two different values. We talk of gender. Gender is a variable because you can have male and female. Whenever you hear gender, you should think of male or female. So it plays a significant role as a level of measurement, as a critical aspect in levels of measurement. And so as a data analyst, it is important for you to understand this. And it is important for you to know that data levels of measurement are critical for you in your analysis. Now, just to progress, we have principally 4 levels of measurement. And so this level differs on how they approach the structure of numbers that we use, right? There are 4 levels and they have different ways that they are approached. For instance, if you want to understand the levels of measurement, we have the nominal level of measurement, we have the ordinal, we have the ratio, and we have what? The interval. We have nominal, we have ratio, ordinal, we have ratio, and interval scales. And so, understanding levels of measurement of variables as used in research determines the type of statistical analysis you can perform. It plays a single role. For instance, when you are doing a data analysis, if you want to use a statistical technique like the independent sample t-test, many times they'll tell you that your data type, your dependent variable should be continuous. So you need to understand what I mean by continuous level of measurement. And basically they're saying that your dependent variable should be measured either in a ratio scale or an interval scale, as you see in this. Now, before we actually dive into the different types of levels of measurement, it's good that we understand some relationship that exists between a variable. Now, each variable we say has the potential to vary. It has the potential to take on different attributes. And so these are attributes. For instance, gender, we have male, we have female and male, right? So these are attributes, this from the attributes. So a variable has the potential to vary. And so whatever the different levels of variations are known as attributes. So you need to understand these attributes because there are the different categorization of a variable. If something of its measure has no potential to change or to vary, we call it a constant. If I say women or female, you discover that you cannot categorize it into different levels when we want to classify it as an attribute of gender. So it is a constant. And here it forms what? An attribute. So we say that a variable varies within a specific study because in another study it might not be a variable, in another study it can be a constant, right? So it's important for understand. Now, qualities of variables. Now, one thing that makes variables to be is that they're exhaustive, which means it includes all possible answerable responses. For instance, when I say gender, we have male and female. Now we have different modifications that are resting, but we're looking at standard meaning of gender, right? Or at times we better say sex. The sex can either be female or male by standard understanding. So you can exhaust the options that are available. Now the next thing is that mutually exclusive. The aspect of mutually exclusive for variables has to do with an item must belong to a single category. No response should be able to have two attributes simultaneously. Remember, we have indicated what we call attributes, right? If we're looking at employment, we can classify our employment into two levels, employed versus unemployed. So it is possible for us to see how we can classify our variable in that case. And so with such a variable, it is possible for us to be looking for that we simply classify. If you are unemployed, you are unemployed. If you are employed, you are employed. You cannot belong in the employment category and unemployed category at the same times. That's why we use the word simultaneously. If you're a male, you're a male. You cannot be male and female at the same time. That's mutually exclusive. If you toss a die, we have 6 options, right? And so the 1, 2, 3, 4, 5, they are one mutually exclusive. If we ask for level of education, at times you may belong to a single category, cannot be in one category and another. The next attribute or quality of variables is that the relationship between variables are assigned, the relationship of the values that are assigned to the attributes of a variable are important. We need to see the relationships that exist between a variable, and that is put, for instance, let's say we are trying to study ethnic groups or ethnic affiliations. Now we go to different ethnic affiliations and we have the attributes here. We have Bakweri, Bakosi, and Bachan. These are different ethnic groups. This different ethnic categorization forms our attributes. Now, for the sake of analytical purposes, we can assign values as 1, 2, 3. So if you assign Bakweri to 1, Bakosi to 2, and Bachan to 3, we're simply categorizing our variables. We're simply categorizing the variables. And so you see that the variables now help us to be able to interact. The variable helps us to be able to interact and see how we can manage our outcome. So, yes, we continue to just give me a second as I levels of measurements, and why they are important in research. So we see that we are into the relationship, and we can help to understand the relationship that exists between our variables. Now, these values establish a relationship, and as we progress in the lecture, you'll see that we will try to say why you need to understand what is the relevance of levels of measurement in data analysis or in statistics. The first principal reason is that it helps you to decide what statistical analysis is appropriate on the values that are assigned. In effect, what are we saying? Before you analyze data, one of the critical ingredients we always say that you need to understand how the data type, which means you need to understand the level of measurement of the data. Is it nominal? Is it ordinal? Is it ratio or interval? Right? Because there are certain analytical techniques that must go with a certain level of data. For instance, if you want to use ANOVA, then we must understand that our dependent variable should be continuous, should be scaled, either ratio or interval. And if that is not, we cannot. Now, it helps you to decide how to interpret your data. Now, why it equally helps you for you to know the statistical analysis to use, it helps you to equally decide how the data can be interpreted. For instance, you won't be able to, be looking for data for a mean value or an average for a variable, say gender, as we've seen, right? You cannot use an average variable for gender because once you add male and female, you do not have a new variable, a new value. You still have male and female. So the additive principle is delimited. So it is important for you to understand. Now, we have 4 categorizations of levels of measurement. And the first one is what? Nominal. There are principally 4 categorizations. If you're using SPSS, you discover that we have 3 categorizations. But in statistics or in research or in data analysis, we have 4 levels of categorization of our data. No matter how the data is collected, no matter where you collect the data, it must fall in one of these categorizations. Now, the first is nominal. Now, this nominal simply represents attributes that are unique. The values name the attribute uniquely. The values name the attribute uniquely, and the codes have no order. What do we mean by this? Now, it simply means that if you're looking at a variable which is nominal in nature, the assigned values, I remember you've seen what we mean by values, do not have any order, they do not have any significant value. For instance, if we have a variable, say, gender, and we give the value 1 for male, right? And 2 for female. We are in no way saying that 2 or female is better than male or twice as better than male, right? The next is ordinal level of measurement. Once you've understand now, there are 3 questions that we always ask. Do we have any possibility of giving an order? If there's an order, yes or no. Can we have equal distances between each variable? Say yes or no. Do we have the significance of an absolute value? Yes or no. Now, let's take, for instance, the attributes of a variable which we can specify around. Now, there is an implied order, which means we can start from the least to the highest. So when attributes can be run, it forms a nominal variable. Now, the distance between they do not have any meaning. The distance between those ranks do not have any meaning. For instance, if you're talking about educational levels, and we have 0 to mean first school living certificate, which is the most basic form, 2 for GCE ordinary level, if you're dealing with a Cameroon educational system, we have 2, which is for A levels, we have degree 4 and post-degree 4. What you notice is that we are in no way saying that GCE level is twice as significant as GCE O level or 2 times higher as that. And we cannot actually segregate a distance, a fixed distance between these. For instance, somebody who has a degree is not as twice as intelligent as somebody. We can say that the person is 2 times more intelligent than somebody with A level. So there is an order, but there's no fixed distance. A good example would be Likert scale item. When we start from strongly disagree to strongly agree, we have that order, but that order do not have what? An intuitive meaning. Now, the next thing is about, do we have an absolute zero distance? At times, we simply try to establish if there is 0 values in our animals. Will 0 make a meaning? Is the distance between 0 to 1 the same as the distance between 2 to 4? That's what we try to establish when we are looking at the possibility of the absolute zero distance. And how I always say that if your data cannot take on values below zero, then we say that there is not absolute zero distance. Now we have the ratio scale. The ratio scale or the ratio measurement has an absolute zero value that has a meaning, right? We can construct a meaningful ratio from our data. And so that ratio is important. So if you want to put our scales, we have the last, which is the interval that talks about the distance. So we have nominal, which is the most basic form. We have ordinal, which there is an order we can put from the least to the highest or lowest, or the highest to the lowest. There is for distant interval ratio, we have a meaningful distance. Somebody, if we give an example in class, and we have 16 examples on 20, and the student has 16 on 20, another one has 8 on 20, we can say that the person with 16 is 2 times better in performance than somebody with 8, because what there is what a meaningful ratio and a meaningful distance between the two. Now we can equally say that somebody with a mark of 9 and a mark of 3 has a distance of 6, and a mark of 9 and a mark of say 13 still has a distance of about 5 or 6 between them, or 14. We have a 6. So we have this equal distance that we can carve out in our data. Now the absolute zero means do we have zero? And a good example would be degrees Celsius. When we measure our temperature in degrees Celsius, 0 degree do not signify the absence of temperature, but it signifies degree temperature at a certain level. Now that is what we have to say with respect to the levels of measurement. Now, before we end our presentation today, I want to emphasize that the levels of measurement are very, very important for any data analyst to understand. It informs you of the type of analysis to use. For instance, if we look at nominal data, the best analytical techniques we could count frequencies and percentages. That is the most basic form. We can talk about frequencies, the number of occurrence of an item, and we talk with respect to percentages. And that is the most main. We cannot add or divide, we cannot subtract. For instance, we're dealing with male and female, you'll not be able to add male plus female to have a new value. And so you cannot take a division to have now a mean. So you cannot take mean for nominal data, you can only take frequencies. Yeah. Now we have ordinal. Ordinal is equally very important, but ordinal helps us to establish if our data has a certain order. Now, if we are dealing with an order, there's a possibility for us to add now, we may add, we may divide, but then it still lacks some of this really standardized. For instance, if we're dealing with strongly agree to strongly disagree, and we give value 1 and 5. In this case, we may be able to add 1 and 5 as a scale, which we have 3, 4 of this. We can be able to add and have a mean. So it's possible for us to get a mean for an ordinal data, but that is not the case with a nominal data. So you discover that parametric techniques are most often more or less structured to use either from ordinal, interval, or ratio. We cannot use parametric technique, we use nominal. And most importantly, we have the ratio and interval, and SPS treat all of them as scale data. So yeah, scale data, which means they have the same attributes. And so with the scale data, as SPS puts it, what you notice is that it is the most advanced categorization of data that gives you room to add, to divide, to multiply, to subtract, and do a lot of additive or statistical techniques with it. And so it is the most advanced statistical technique that you need to use when you are doing your analysis. However, what we are insisting is that these levels of measurement are important because they inform you on how your data was measured and what statistical techniques are possible that will give meaning to your data. Now, most statisticians have categorized this data level into two. We have this to be categorical data, which means our data can take on categories. And we have continuous data for these other two, the continuous. Now, we look at continuous data as data that has the potential to take on different values. If I ask your age can be 12 today, your age should be 14, maybe 14 in the next 2 years, 14 years, it can be 12.25, although we hardly want to put years as such, but then you can see that we can 12.25 will still give us meaning. So continuous data can take out even decimal places and will still give useful information. And there are limitless options that you can take. For instance, with categorical data, if you're dealing with gender, we have limit options like yes or no, or male or female, yes or no, true or false, ratio, ordinal, we can have strongly agree to strongly levels of education, is that there are finite options. But with continuous data, it might be finite, but then we have a lot of possibilities. And so that is the difference between categorical data and scale data or continuous data. Now, with this, I believe you have some better understanding of levels of measurement. Just as a recap, a variable in a study is any value that has a potential to take on different value, which may has potential to change. That's what a variable is. And apart from that, you have to understand that a variable has attributes, and these attributes are assigned values. These values determine how your data can be analyzed, right? And we said we have different 4 levels of measurement: nominal, ordinal, interval, and ratio. And all of these levels of measurement are relevant because they inform us on the type of analytical technique that is possible and that will give meaning and how we can interpret our data. We went further to say that we can categorize our levels of measurement principally into two, as categorical data and the continuous data. Continuous data, we can have discrete and we have ratio, which take on decimal points. So having said that, I believe you've gotten an understanding of what levels of measurement are and why you should understand them, because they play a significant role on how your data should be analyzed, on how the data should be analyzed, the analytical techniques that are possible. And so in a subsequent lecture, we'll take examples and show you how we can apply this. But remember, example of nominal data is gender, example of ordinal is level of education, example of interval data could be marks in class, GPA, and ratio data we can even take on temperature measures in degree Celsius. So thank you for being part of today's video, today's interpretation. We recommend that what you should do, if you like the video, find the video, you should like, subscribe, as well as share, right? Share our videos, but most importantly, subscribe. So we are Firstlinks Academy on Facebook, on Twitter, on Instagram, on YouTube, Firstlinks Academy. Just like, and we recommend that you click the subscribe button and the notification so anytime we are live, you'll be able to have it. Whether you're watching this video on YouTube or on Facebook, like and share. And thank you, and see you in our next video. I am Tingo Pedman for this presentation.